Alright, so today I'm going to tell you guys everything I did to set up and install a good working environment for Clojure and Clojurescript. This video is really focused on setup and installation, so it's not a general programming tutorial, but it's all the main tools that I use in my day-to-day work. And I think it's just really useful to remember how I got everything set up and installed. Alright, so in order to make sure this is a fair fight, I'm going to start by spinning up a new Ubuntu instance on AWS. This is just going to ensure that we're starting with a clean install, and so that we're not missing any steps that you might need if you got started on a new machine. Alright, so I'm just going to SSH into the server. If you were running this on a local machine, you would open up the terminal and enter all of these same commands. Now, this guide is my personal experience. It's not an official manual or anything like that. So, obviously verify what you're doing and make sure it's up to date before running stuff on your local machine. Now, the first thing that we're going to be doing is we're going to install this tool called linengin. It's one of the main tools that people use to build and organize Clojure projects. And conveniently, it also installs Clojure itself. You can install linengin from a package manager just by following the instructions on their website under packaging. So I'm going to follow the Debian instructions and I'm going to do sudo apt-get install linengin. Now, this should also install Java as one of the package dependencies, which you can check by calling java ---- version. But if for some reason it doesn't, you can also use your package manager to install Java directly on your machine. Alright, so now once linengin is installed, you should actually be able to create and run your first Clojure project. So in order to create the project, I'm going to run this command line new and then give it a project name. So I'm going to call it test project. And then I can see it created a directory for the project. And inside of the project, there's a whole bunch of files. Kind of the main source code is under the src directory for source. And so right now I can see that the source code for this project is just this one file, core.clj. So I'm going to open it up and take a look at it. Actually, first I'm just going to really quickly install emacs just to make it really easy to open and look at the file. When I install emacs, I'm going to choose no mail server configuration. Alright, so now I'm just going to open up emacs and view the file. So it's under test project /src test project core.clj. And I can see it's this mostly empty file with just a single function that prints out hello world. So if I want to go ahead and I want to run this function, I can just cd into the project directory and then run it with line run -m test project.core/foo. So the first time you run this, you'll see that it downloaded a whole bunch of dependencies. These are just all the external build dependencies of the Clojure codebase. And then it ran the function and it actually errored out and it tells us that we passed the wrong number of arguments to testproject.core/foo. So if we go back to our main core.clj file, we see that foo actually accepts an argument. So when we call the function foo, we need to give it an argument there as well. So now if I go back and I call the same command, but I give it an additional argument, then I see that it runs the function foo, and I get the printed output as expected, which is Sammy and then the string hello world. Now we're going to take a moment and figure out what does this command actually do. So we called line run -m test project.core/foo and then Sammy. So line is short for the tool name linengin. Run means we're telling linengin to run some Clojure code. -m means use this function as the main method of our program. It's basically saying this Clojure function, testproject.core/foo, is going to be used like our Java's main method. So it's going to be the entry point for the whole application that gets run. And then we have our command line arguments, And here we passed the string Sammy. And so those get passed as string arguments to the function foo. Now I could put any function I want in here. So if I did something like I wrote a new function bar, note that when I'm at the command line, I have to use the fully namespaced function name. So that's testproject.core/bar instead of just bar. So now I'm going to save this. And if I go ahead and I run this, now passing in 2 arguments, I get the result, which is exactly what I would expect. This extra new line here isn't from the program. I just hit enter an extra time while I was doing the command in the terminal. All right, so you can take your program, give it a main method, and then run it from the command line, just like you would any other Java program. But what's really neat about Clojure, and one of the things that people really like about it, is the ability to start up a REPL and then do some interactive development. So if instead of calling run, I go ahead and I type line REPL, I can actually go ahead and develop on this project. It gives me a little interactive environment that I can use to do just like arbitrary Clojure code. So for example, if I wanted to call the function foo, I could just write the Clojure code foo of Sammy, and it would show me the result and also the return value. Now this is really special and it's really different than what we did before because it lets us execute stuff inside of the context of a running program. So for example, I could define a variable x to be the string engineering. And then if I call foo of x, it prints the result with the variable applied. And so this is really similar to a Python interpreter or any other interpreter or debugger that you might be used to. And it's really, really useful for iteratively building applications. Now, something else that I just want to point out here is that when we ran this command, line REPL, by default, it put us in the namespace testproject.core. And that's why we were able to call foo without requiring the namespace or putting a namespace in front of the symbol. But if you wanted to use a different namespace, you would need to require it in order for it to run. All right, so line REPL is a really nice way to get up and running. And it's also sometimes useful as a good fallback. But that's not the way that most people actually develop and work on Clojure programs. So the next thing that we're going to be doing is I'm going to take you through my development environment setup using Emacs and Cider along with a couple other packages. And I'll show you how I get up and running with a good working environment. So first I'm just going to open up Emacs, which as you remember we installed earlier. And then I'm going to type metax package list packages so that we can install some packages into our Emacs. This isn't a full Emacs tutorial. It's really going to be focused on the Clojure aspects of setting up your Emacs environment. So if you want like a general introduction to Emacs, if you're not familiar with that, it might be worth it to check out something like that first. So the first thing that we're going to install is a package called cider. So I'm just going to search for it inside of this buffer. And then to install it, I'm just going to hit enter and then Control-X-O to switch window, and then navigate the cursor to this install button and then hit enter. As you can see, this also installs Clojure mode and a couple other relevant dependencies. So that's really neat. So we don't have to install those separately. While we're at it, I also want to install this package cljrefactor. It's only available through Melpa. So to even find it in the package list, we're gonna have to open our .emacs file. So that's under just your home directory and then .emacs. And then we're gonna add the following line of code, add to list package archives Melpa, which basically just tells Emacs where it can go to find the package that we're looking for. And then I'm gonna go ahead and I'm gonna execute this. So I'm gonna hit Control-X, Control-E to execute this. And then I'm gonna call package list packages one more time. And I should be able to find CLJ refactor. So I'm just gonna hit enter on this and then install that as well. Yes. Okay, so now I'm just going to go back and I'm going to open up our little Clojure project that we created earlier. So I'm going to go to test project /src/test project and then core.clj. All right, so I'm just going to open this up. And as you can see, after we got all of that stuff installed, the whole file looks way different. So now that we've installed cider mode, and then by dependency, the Clojure mode extension, Clojure mode is now enabled by default whenever we open up a Clojure file. So that means we get all of this syntax highlighting and a whole bunch of other really nice stuff. So now the first thing that I'm going to do is I'm going to open up a REPL and connect to it. This is going to be just the same as the interactive REPL that we opened up earlier, but it's going to be connected to our emacs session. So we can evaluate code to it directly from this file. So now I'm going to call metax cider jack-in to open up a REPL and connect to it. This might take a moment to start up. It'll take even less time if you're not running it on a tiny AWS box. At this point, there was this warnings buffer that kept opening up. So I'm just gonna go into my .emacs file and add the following little snippet of code to turn all the warnings off. And then hit Control-X, Control-E to execute it. All right, so now I'm gonna go back to my main Clojure file. And after you run cider jack-in, what you'll get, it might not open automatically, but you'll get this buffer that starts with *cider REPL, which is sort of the equivalent of the line REPL that we were just working in. Now, something that makes working with Clojure and Emacs just an absolute joy is you can go into a file that you're working on, move the cursor to the end of any expression, and then hit Control-X, Control-E. And it evaluates that expression directly into the REPL. So if I have any expression at all, I can hit Control-X, Control-E to execute it, and it executes this expression directly into this REPL. And this is really powerful. I can even use Control-X, Control-E to execute things like namespace and function definitions. So for example, if I'm working on a new project, I could define a new variable x, execute this statement with Control-X, Control-E. Then I could define a function, add 5, that takes its input and adds 5 to it, and hit Control-X, Control-E to define this function. And then I can call this function on our variable x, and then hit Control-X, Control-E to view the result. So this lets us sort of develop interactively and evaluate the program as we go along. Usually when I'm working on a piece of software, I'll write bits and pieces of code and then evaluate them to make sure that they work in the way I expect them to. And then once I'm confident that they work the way that I think they will, I'll move them inside of a function definition and then evaluate the result to make sure it still works the way that I expect it to. So it's a great way to verify that things work the way that you think they do while you're actually in the process of writing the software. And then at the end, you've already done most of the work of defining the unit tests as a little treat. A lot of the time when I'm working on software, I like to put in development code inside of a comment block so I can kind of test stuff out and experiment without interfering with the flow of the main program. Now, I'm not going to go through every single thing that Cider does, but I just wanted to show off a few of the tips and commands that I found to be the most useful. So we've already seen that you can use Control-X, Control-E to execute an expression. It executes the entire expression up to the matching parentheses. So if I put my cursor here and I execute this, it'll execute the entire if expression. But then if I put my cursor here and I execute it, it'll just evaluate this Boolean condition, which is true because x is greater than 3. Now if I'm inside of the middle of this expression, I can hit Control-C, Control-C, and that evaluates this entire if statement, even though my cursor is somewhere in the middle of it. And I find that this is really useful for editing and saving functions. So if I'm inside of the middle of this function and I want to change this add 5 to an add 6, then I can just hit Control-C, Control-C. It evaluates this top level form, which is a function definition statement. And now if I go ahead and I add 6 of 3, I can see that this function was correctly defined. Another thing that I find really useful are key commands for moving in and around code with this sort of parentheses syntax. So if I'm somewhere in the middle of an expression, I can hit Control-Meta-U to move the cursor to the beginning of the expression. I can hit Control Meta F to go forward one expression and Control Meta B to go backward one expression. And I can use these commands together to sort of structurally move around between different pieces of code. So for example, if I'm somewhere inside of here and I just want to evaluate one of the inner expressions, I can do Control Meta U to get my cursor to the top of this expression, Control Meta F to get my cursor to the end of the expression, and then Control X, Control E to execute it. Now I have a bunch of emacs extensions that I use to make all this editing and typing a little bit easier. So the first thing that I do is I remapped my 9 key and my 0 key to be open and close parentheses respectively. And I basically just swap the keys. So if I actually want to enter a 9 character, I can hit Shift 9 on the keyboard and it'll enter a 9 as normal. I also have some of my own custom emacs extensions that I wrote just to make the process of editing and working with Clojure code just a little bit easier. This is all available and open source on my GitHub, so feel free to check it out and try it for yourself. This is one of my favorites. So it basically just lets you save a Clojure expression to a key binding and then execute it again by calling that key binding. So what I'm going to do is I'm just going to go to code over here and then copy this URL. And then I'm going to go back to my terminal window, do git clone to clone this repository. And then I'm going to copy this file to my emacs directory. Actually, I like to put all of my custom extensions inside of their own special custom directory. And then I want Emacs to actually load the file when it starts up. So I'm going to do add to list load path emacsd/custom. And then I'm also going to require the library cider save command. Annoyingly, I had to modify the key binding slightly because my terminal wasn't correctly sending the character code for control 1. But if you're just using this package normally, it isn't something you'll need to worry about. So now if I go ahead and I exit out of Emacs and I reopen it again, and I reopen up my test project and also start cider, and then I put my cursor at the end of this expression and I type Control C, Control S, Control 1, then that will save this entire Clojure expression. And then if I'm somewhere else in my code and I want to go ahead and I want to use that later, I can hit Control C, Control 1. And it'll evaluate just that expression I saved. So you can see the answer 161 printed at the bottom of the screen. Now, I find this super useful. Obviously, I wrote it, so I have a reason I really wanted this. But the main way that I use this is actually when I'm editing Clojurescript code. I find it really, really useful to save the commands to reload my React DOM. So I have more control over when certain elements on the page get reloaded. All right, so now we're going to set up a Clojurescript project. When I first started out, getting set up and running with Clojurescript was something that I found to be the most confusing out of everything in the whole ecosystem. There are so many different build tools and files and systems that people have for organizing and building and working with Clojurescript. And there's no real consensus on what tools you actually need to use. And it took me a really long time of digging through comment threads and trying stuff out for myself until I found a working environment that was functional and got all of the tools working correctly. So in this video, I'm going to go through the setup of a Clojurescript front-end project. So that's basically writing a front-end UI with React and Clojurescript and then sending it as JavaScript to the browser. If you don't know what that is yet, don't worry. I'll explain the basics as part of this video. But I'm really hopeful that by going through the system of tools that works for me, I can really help cut through some of the confusion that I first faced when I was trying to figure out how to build Clojurescript applications. So in order to start a new Clojurescript project, you don't need a setup script or anything like that. You just need to make a source code folder with a Clojurescript file in it. So what I'm going to do here is I'm going to go in and I'm going to create a new folder for the project. Inside of this folder, I'm going to create the same directory structure that we had before. So I'm going to create just a source folder with a single directory inside of it. And then I'm going to create a Clojurescript source file, core.cljs. And then I'm going to write a simple little Clojurescript program that just displays an alert telling the user that the JavaScript file was successfully loaded. Now, the way that Clojurescript works is you write Clojurescript code, just like any normal Clojure code that you're used to. But then there's this special thing called the Clojurescript compiler, which takes your Clojure code. So it takes this file that we've just written, and then it runs a program on it that converts it into a JavaScript file. And then once we've converted it into a JavaScript file, then we have something that we can send over the web to different web browsers, and that basically runs anywhere that JavaScript can run. So what we want to do now is we want to take this file and we want to run it through the Clojurescript compiler so that we can convert it into JavaScript. And so before we actually run the Clojurescript compiler, we need to create one more file called deps.edn in the top level project folder. And what this file does is it just tells the Clojurescript compiler how to compile the application. So it's basically some additional metadata, like all of the build dependencies and stuff that gets used by the Clojurescript compiler. Now there's a ton of different compiler options that you can put in here, but I'm going to stick with the simplest ones when we're starting out, just to make life a little easier. So in order for the Clojurescript compiler to run, this file needs to contain a Clojure map. So these are the external libraries that our Clojurescript code depends on. Right now I'm just going to put Clojurescript because we don't have any other external dependencies. But if you had more external Clojurescript libraries that you wanted to use, you would put them here. And then I'm going to add paths, which is just the location of the source directory. So our source directory was under /src, so our paths is going to be src. Okay, so now in order to run the Clojurescript compiler, I need to download and install it. So I'm going to be following the instructions on the Clojure website under the guide install Clojure. So what I'm going to do is I'm first going to install bash, curl, and rlwrap, and then I'm going to copy paste the installation instructions from the Clojure website. And after I run these, the Clojurescript compiler should be successfully installed. So now I'm going to cd into my project directory. So I'm going to make sure that I'm in the top level CLJS project. And then I can now run the Clojurescript compiler to actually compile the application. And so what I get out is I get a directory CLJS project /out containing a JavaScript file main.js. And this JavaScript file contains the JavaScript source corresponding to our Clojure application. Now, this JavaScript source file does include some other JavaScript files from the same directory. So if you want to use it, you actually do need to make sure that your entire out directory is accessible on your server. Now, this sort of simple compilation isn't usually what you would actually use on a production server. It includes a lot of debug information, and it's also not like compressed or minified to reduce the amount of bandwidth you need to actually send the JavaScript files to the user. And so you would actually give the compiler slightly different instructions to generate a file that was more suited to production use. And so to go ahead and sort of tell Clojurescript to produce output that's more suitable for production, I'm going to go ahead and create this file prod options.edn. And then inside of it, I'm going to put the options that I want to use for my production environment. So in this example, I'm going to use optimizations advanced. And that's going to tell the Clojurescript compiler to do more advanced optimizations and also not include as much of the debug and dev information. Okay, so now to go ahead and actually use this, I'm going to open up a shell, and then I'm going to recompile. But inside of my command, I'm going to type -co and then prod options.edn to use my production options when I run this compilation. And now if I go ahead and I execute this, and then I open up the file with my JavaScript output, I can see that instead of including a dev file, which just imports a bunch of other stuff, what I get back is a bunch of condensed and minified JavaScript representing the actual code of my project. And you can even see the alert command written out here. Now, it's super important to use advanced optimization because you'll get smaller JavaScript bundles and your websites will just load a lot faster and just work a lot better. But you have to be super, super careful when switching from normal optimizations to advanced optimization, because sometimes there are certain compiler warnings or issues that you can sort of ignore during normal compilation that will fail if you switch to advanced compilation. So even though development compilation is super useful for just like quick development and just like getting things done, you really need to regularly compile your application with optimizations advanced. And this is something that I've run into before, because if you work on a project for a really long time and you suddenly switch to compilations advanced at the end, you'll see a whole bunch of issues pop up and you'll think that optimizations advanced is broken and that nothing is working. But in fact, usually what happened is there was something in your project that was technically supposed to be incorrect, but that was allowed by the dev compiler that shouldn't have been. And you won't know that this is going on unless you compile with advanced optimization semi-regularly. All right, so this is the default Clojurescript compiler, and it's the fastest way to get up and running and get started running Clojurescript applications. But really importantly, we're not done yet. That's because most people, when they compile Clojurescript, don't actually use the vanilla Clojurescript compiler. They use a different tool called shadow-cljs, which is a separate thing that's built on top of the Clojurescript compiler and adds a whole bunch of extra features. Importantly, shadow-cljs correctly imports dependencies from NPM projects in a way that the default Clojurescript compiler does not. And so if you're using a project that was designed to be compiled with shadow-cljs, and you try to compile it with the vanilla Clojurescript compiler, the dependencies won't get loaded in and the application won't work right. So if you want the really short, just like my opinion, I think you should use Shadow instead of the Clojurescript compiler and just like not worry about it. This is one of those things that's sort of ambiguous and really not well documented. But in my opinion, because of the way that it handles NPM modules, shadow-cljs is sort of mandatory for a lot of Clojurescript development. So with that said, let's get started and let's set up shadow-cljs for our project. This section is going to assume that you've already done all of the steps in the previous section. So you've created a project and initialized it with a deps.edn file. And then I'm going to run this command npm install shadow-cljs. Looks like I need to install npm first. So here I'm going to follow the instructions at node source/distributions. And I think we've already installed curl, so I'm just going to start with the rest of the commands. So that is just downloading the setup script, then running the setup script, and then actually calling apt-get install to install the application. Okay, and then we'll just verify that it's up and running. So that looks good. And now we can call, I actually probably want to remove the setup script from my project directory now that I've already used it. So now I need to initialize npm for my project. So I'm going to do npm init-y to initialize npm with the default options. And now I can finally call npm install shadow-cljs. Okay, so now that the package shadow-cljs is installed, we also need to initialize it. So I'm going to call npx shadow-cljs init. And this is going to create this file, shadow-cljs.edn, which is sort of similar to our deps.edn file that we created earlier. So it's basically just a file with some extra information that tells shadow-cljs how to compile our application from Clojure into JavaScript. So just very quickly, I'm going to open this up. So I'm going to open up the file shadow-cljs.edn. And I can see that it gives the source directories for our project as source, dev, main, and test. I really only have one source directory, so I'm just gonna delete all of these and change it to one src directory for all of the source paths. Now we already have a deps.edn file and we actually want to use deps.edn to manage our dependencies. So what I'm going to do is I'm going to delete this dependencies block here, and then I'm going to add in deps true. To tell shadow-cljs to use the deps.edn file to manage the project's Clojurescript dependencies, rather than using Shadow's own Clojurescript dependency management system. The reason for this is that deps.edn does a better job handling local project dependencies. So if you have a project and you also have a local Clojurescript library that you're working on, and you want the projects to sort of depend on each other, I think that deps.edn does a better job of handling that. So for our project, we're going to use deps.edn to manage our Clojurescript dependencies, but we still need the shadow-cljs compiler in order to handle npm dependencies. Next up, we want to add our build into the list of available builds. So I'm going to create a new build and call it app, and then I'm going to give it an output directory of out. I want to show you guys how to build a front-end project, so I'm going to set the target of this build to be the browser. And then I'm going to give it an init function. This is sort of like the main method of the JavaScript program, and it's what shadow-cljs runs every time you reload the page. So I'm just going to give it an init function of cljsproject.core/load page. And we'll write this function in just a sec. So now I'm going to save this, and then I'm going to go back to our projects, and then I'm going to create this function load page, which just alerts that the file was loaded into the browser. Okay, and then I'm going to go ahead and save this, and then go back to my shell. And then in order to compile from Clojurescript to JavaScript, I'm going to type npx shadow-cljs compile app. It looks like this is telling me that I need to move my source paths into deps.edn. So I'm going to go ahead and cut this from shadow-cljs. And then while I'm at it, I also want to add the dependency for shadow-cljs into my deps.edn file. So I'm going to go ahead and add the following dependency into my deps.edn to make sure that shadow-cljs is included in the project. And you really need to do this if you use deps.edn to manage your dependencies. So now if I go back to my terminal and I recompile this, I can see that it successfully compiled my application. Now, just like before, this is the dev compilation mode. So if I want to go ahead and compile this for a release build with all of the optimizations and stuff, I need to go ahead and do shadow-cljs release app. And this does the compilation with all of the advanced optimizations and stuff applied. Now, usually when I develop on a Clojurescript project, I do it as part of building a website that also has a real backend. So just for demonstration purposes, I'm going to make a little backend web server that serves our generated JavaScript file. So I'm going to cd into my home directory, do line new sample server to create a new project. Inside of the sample server is project.clj. I'm going to add dependencies for ring and composure, which are just two libraries that I'm going to use to help me build our little web server. And I also want another library called hiccup. And then I'm going to open up the core.clj file. So now I'm just going to code up a simple little web server in Clojure. This isn't a Clojure programming tutorial, so I'm not going to go over how to write a Clojure web server in a lot of detail. But basically all this does is it responds with a web page that serves our JavaScript output file that we've just compiled. And so you can see here it's serving files from the CLJS project output directory. I actually had to update this to the full path so that it would load the file. So now if I go ahead and I run this, so line run -m sample server.core/ don't need an input mode /run web server. It starts up the web server and has it running on port 8003. So now I'm just going to quickly make the port available on AWS. This isn't the way you would normally do it. Normally you would use something like Nginx to manage this. But this is just sort of a quick way we're going to do it to get on with the tutorial. So now if I open up Chrome and I go and I load this web page, I can see the alert that it successfully loaded the Clojurescript file. So now we are cooking. We've successfully compiled a Clojurescript file and loaded it in production. Now, just like before, these command line tools are really useful for getting started with Clojurescript and getting up and running. And they're also really useful for compiling and releasing your projects. But during development, running the commands directly from the command line isn't what most people do when they're actually working on a project that's in progress and they're kind of playing around with in development code. So in this section, I'm going to teach you how to develop on Clojurescript code using cider and emacs in a way that interfaces with the shadow-cljs Clojurescript compiler. And this is the way that I currently work on and develop Clojurescript applications. So before we get started, we need to talk a little bit about how JavaScript programs are actually evaluated. So JavaScript is designed to run in the browser. Obviously, certain commands like JSAlert don't make sense unless you have a running browser open that's running your JavaScript process. So in order to actually open up a REPL that makes sense in the context of our front-end application, we need to open up a browser and load a web page that imports this JavaScript file, so that we have a workspace where we can actually develop and execute REPL commands. So to get started, I'm going to go to my Clojurescript file and I'm going to run the command cider jack in cljs. Now it's going to give us a couple of options here. Clojure CLI is the CLJ command that we saw earlier, but because we've set up our project with shadow-cljs and that's what we want to use here, I'm going to go ahead and type shadow-cljs. Then for the Clojurescript REPL type, I'm also going to select shadow. And then the build that I want to build is app. Now, unfortunately, I don't have a web browser installed on my Linux box. So it's trying to open things up in the Emacs web browser, which is not what I want. So I'm just going to not open this window for now, but I'll show you how this works on my local computer in just a minute, just to give you guys a sense of what's going on here. So now if I go into Cider and I go ahead and I type out a really simple expression and I try to evaluate something, it gives me this error, no available JavaScript runtime. And basically what that means is that I don't have any browsers open that are running this JavaScript code. So there's no environment that the actual project code can be evaluated. Now Shadow has sort of a default static website that you can open up in the browser and that serves your JavaScript file. But when I'm developing an application, especially when I'm working on a full website with both a front end and a back end, I like to connect Shadow to a web page served by my server so that it works sort of the same way that it would in production. So I'm going to go ahead and I'm going to start up the sample server that we created earlier. And then I'm going to go ahead and just load the website in a local browser. Now, as mentioned, my remote server doesn't actually have a web browser on it. So in order to make it available remotely, I had to make sure that the web server could accept incoming connections from the port that Shadow runs on. But if you're just doing this locally on your own computer, then this isn't something you need to worry about. Okay, so now that I have everything set up and connected, I can go ahead and go into my Emacs window and I can put my cursor at the end of a statement and I can hit Control-X, Control-E, and it will execute that statement in Clojurescript and return the result. So now what this is doing is sort of on the fly, we're converting this Clojurescript expression to a Java expression, and then we're evaluating that JavaScript expression into the JavaScript console of this browser. So for example, if I had a Clojurescript expression like this, I can go ahead and execute it, and it would convert this expression into the equivalent JavaScript and then execute it in the browser. Now, what's really neat about this is we can go in and we can actually execute commands that affect the state of the web page in the browser itself. So if I wanted to go ahead and set the default color style of the body to be red, And then if I go ahead and I execute this, I can see that it changed the color of the text inside of my browser window. So that means that I can execute code directly from the file that I'm working in to the actual web page that's running my front-end application. And this is super, super neat and super, super useful. It means we can use that same style as before, where we kind of play around and build up expressions and function definitions sort of on the fly, but actually do it with the visual view of our front-end application. So we can really interactively develop the UI for the application itself. And this is just really, really exciting and really, really useful. Now, Shadow actually does something really interesting. And this is not something that's done by the vanilla Clojurescript compiler. Is when you're editing one of your Clojurescript files and you go ahead and you save your application, Shadow actually recompiles your Clojurescript project and then refreshes the contents in the browser to use the latest version of the JavaScript source. Now, this is really similar to IDEs for developing React applications, if you've ever dealt with anything like that before. Now, there are various ways you can customize this, like you can control which functions get called when the web page does refresh. But I personally don't like dealing with this, and the main reason is that if I'm working on some in-progress code and I save it, it attempts to refresh the page, and it gets this really messy error message that just takes me out of whatever I was working on. So I actually have my own strategy for dealing with this, and I think you'll find it quite interesting, even if you're an experienced Clojure developer. So what I actually do is I just turn off auto-compilation entirely. I actually couldn't figure out how to do this at first. So I actually reached out over GitHub, and Thomas Heller responded almost immediately with an explanation of what to do. So shout outs to him for running a very well supported and well maintained project. Anyway, the way that you do this is you go into your shadow-cljs.edn file, and then you add this line, DevTools auto build false. And this basically just turns off auto build for your project. So now if I go back into my original file, and I'm going to quit out of Cider and restart it, and then also reload my web page. The first time I reloaded it, I got an error, so I actually just had to reload it again. And now if I go ahead and I enter a bunch of garbage into my file, and I go ahead and I save this, then I get no error message, which is great because I like to type a bunch of garbage while I'm working on in development code. All right, so we've turned off auto builds, but it is still convenient to be able to refresh your source code to see the latest changes of whatever you've been working on reflected in the browser. So I actually have my own strategy for doing this. So basically what I do is I rely on this emacs library, cider save command, which I talk about earlier in the video. And basically what I do is I put all of the code for my web page inside of this load page function. So if I wanted to reload the page, I would just call load page, and it would rerun all of the JavaScript that I would want to execute when I refresh the application. So this is usually just a call to React DOM render to reload the React DOM or something like that. And then what I do is I comment out this bit of code and I call cider save command on this expression. Then if I'm editing my Clojure file and I want to refresh my application's JavaScript, I can just type Control-C, Control-1, and it executes this saved expression, which reloads the contents of the entire page. And what's really nice is I didn't have to save here, and even if I was working on some scratch, just like unfinished code at the bottom of my file, I can choose which bits and pieces of the application I want to refresh on the fly, just by choosing which function definitions to reevaluate before making this call to load page. If you are skipping around in the video, cider save command is a little Emacs util that I wrote specifically for this purpose, and it's open source, so there's a link in the description and also instructions on how to install it earlier in the video. All right, last up, I want to talk about what is, in my opinion, the defining feature of shadow-cljs, the ability to quickly and easily import external JavaScript dependencies. So if I have an external JavaScript library that I want to load, I can install it directly with npm which is sort of the standard package manager for JavaScript projects. So if I want to use this JavaScript confetti library, I'm going to go ahead and I'm going to do npm install JS confetti. And what's really cool is shadow-cljs lets you convert this JavaScript import statement directly into an import statement that you can use to require it in Clojure. So now if I go ahead and I restart Cider, I can go ahead and follow the instructions to add confetti into my web page. And now if I go ahead and I execute this, I can see confetti in my page. Now, this is sometimes a little bit tricky to get right. Shadow has instructions in their user guide on how to convert JavaScript import statements into Clojure import statements. But every once in a while, it takes a little bit of fiddling to kind of get everything to work right. I also sometimes turn auto build back on when I'm in the process of importing external JavaScript library, because it just makes the process of iterating on it just a little bit easier. Anyway, that's all for today. Thanks so much for watching until the end. If you enjoyed this free educational content, obviously give the video a like, subscribe to the channel, and I'll see you in the next one. Also, believe it or not, there's a lot that I wanted to say, but that I didn't have time to in this 50-minute video. But if you have any Clojure tips and tricks that you think I missed, I would love to hear about them. I would love to, always looking for ways to improve my own workflow. And yeah, I would just be really curious to hear everything that you guys are doing. Anyway, thanks so much, and I'll see you in the next one.